Hello and welcome, everyone. I'm Jim Olson, Assistant Executive Director of the National Tile Contractors Association, and thank you for attending today. Today's webinar, titled, How Does Moisture Affect Tile and Stone Installations? This presentation will discuss how moisture from various conditions is a factor to consider with today's construction practices in tile and stone installation assemblies. In this presentation, we'll discuss what to consider on your next project to avoid or prepare for these effects. The sponsor for today's presentation is Custom Building Products. And before we begin, I have a little bit of business to take care of. Today's webinar will be muted. Please use the participant feedback or the chat screen on your computer to ask questions. Type them in and we will answer them at the end of this presentation. All our webinars are archived and available to watch at any time after the webinars are presented. Please email your request to me. I will provide my email address on the chat screen once we begin. If the audio on your computer is poor, call the number on your chat screen to listen on your phone. Today's speaker, Mike Micalizzi, is the Senior Director of Technical Services for Custom Building Products. He is based at their research and training facility, Custom Technical University, located in Santa Fe Springs, California. In this role, Mike assists industry professionals with recommendations on commercial projects, presenting a variety of installation challenges. He also presents the Top 5 Tips educational video series for tile contractors and design professionals. Prior to becoming involved in the product technology, Mike owned a tile and stone installation company in New Haven, Connecticut. He currently serves on technical committees for the Tile Council of North America, Materials and Methods Standards Association, known as MMSA, National Tile Contractors Association, Marble Institute of America, American National Standard Institute, and the ASTM International. Welcome, Mike.
Thanks, Jim. Thanks for the opportunity to speak today. I guess I should start going then. So thank you everybody for joining the webinar. Our discussion today is how does moisture affect tile and stone installations? Because today moisture is something that we really do have to consider in all of our flooring and our vertical applications. If we take a look at our first slide here, I'm sure all of us as tile contractors and those in the business can recognize what's going on with this flooring. And typically when we think of moisture, we think of moisture affecting vinyl or carpet or rubber or other materials more so than we would ever consider tile. But the reality is, in these applications, it's not just the flooring that's being affected. If we look at the adhesives that are underneath these floorings, we can see that many of them are breaking down because of moisture, and that's in the floor covering business. So we think about other issues, for example, with hardwood and laminates. They're not able to resist moisture and what the effects are as well. When we think of the consideration of laminates and hardwood, you see in these pictures where an excess of moisture is going to cause these materials to move. And when we think of where the industry is going, there are claims made that flooring is totally waterproof, totally beyond the scope of moisture that won't be affected. Well, the reality is, down the road, many of these owners and users are going to learn the hard way that moisture does affect all of these materials. When we consider ceramic tile is specified in areas where there is a lot of moisture. It's hard sometimes to help a business owner or homeowner to understand what's going on with their tile installation, because look at that picture. I mean, the amount of moisture, the amount of water that's going to affect that tile and surround it, no one would assume that this installation would ever or could ever be affected by moisture. In fact, so many applications where tile and stone are used, we see them totally submerged for many years. So how is water and moisture going to affect a tile installation? Well, in order to talk about this and understand where we're coming from, we really need to understand, what is the definition of moisture. So according to the definition, it's water or other liquid diffused as a vapor or a gas, and it's within a solid or condensed on a surface. So those are the two types of areas that we're going to consider where moisture is a factor, whether it's in a solid material, such as a substrate, or is condensed on a surface, and how that affects a tile installation. So most importantly, these effects need to be considered before. I mean, we wouldn't want to have to go back and try to figure out what happened. That's not where we want to be in our industry. So we have to consider the effects before an installation. And at times during the installation, moisture can be a factor. And then what could happen after an installation, we really need to protect the people who are purchasing these products, as well as, if we're installers, to let people know what could happen if we don't address moisture ahead of time. So what could happen? Well, absolutely there could be a failure with a tile and stone assembly. As we see here in this picture, the tile itself isn't damaged, the mortar isn't damaged, but yet due to the excessive amount of moisture, that moisture caused a condition such as efflorescence that is expansive, and this efflorescence caused a failure with the tile. So we can see that moisture can affect the assembly of the tile, and we'll talk a little bit later about the tile and stone themselves, if we don't consider them. So the first thing we want to talk about is, well, what are the sources of moisture that we have to factor in? Well, the most obvious is concrete. We realize that when concrete is placed, there's an excessive amount of moisture and water that's used in the mix in order to place it, and it's absolutely necessary in order to make the concrete and form it and shape it and finish it. The point is, though, is that where does all that moisture go, and how long does it take to go away, and does it go away sufficiently so that if we install over this material, we're not going to have issues with our tile installation? That's what we're going to consider. How do those factor in? The other thing to consider are the unexpected. Every one of us has been in a situation, if you're a contractor, where you've been on a project and weather conditions are going to affect the site. Anytime we have a lot of moisture on a site, it's going to hit into the ground. It could help, or it could affect the materials, the structure, the framing. Having a basement full of water could cause an excessive amount of moisture in order to appear into your installation and be absorbed into the materials. So not only the normal considerations, but we also have to be ready for those things that come up against us when we're actually installing. As in the case of this picture here, when we think about a place of moisture after a VCT is removed, and you look at the floor, you can actually see the residual moisture coming to the surface and condensing on the surface of the concrete. But it's not always so obvious where we could see that moisture, but we know it's there. If we look at the list of substrates that we are going to install our tile over, we consider that within a solid, we have a concrete slab, we have parge coats or renders, depending on what side of the country you are. You'll call them a parge coat or a render. Plaster coats, mortar beds, CMUs, or we think a block or CBU, cement backer units. All of these, having cement, are going to absorb moisture from its surroundings. Some of the moisture is going to be in the installation, in the mixing process, adding water. And the other condition is that once in place, weather, humidity, all these things could add moisture or delay these products from fully curing out for an extended period of time. When we consider that, not only are we going over cement products, but we're going over wood products. For example, engineered joists. If you have joists on a project, whether residential or commercial, and they're not protected, and they're subjected to water, rain, moisture, those engineered joists can lose their rigidity, lose their strength, and although you planned for those joists, or you were told those joists were going to meet a deflection rating of, say, L over 900 or 700 or what it might be, because they were affected by moisture, you could significantly drop the amount of deflection resistance down to a lower amount, and now your 24-inch on center framing in your floor is not going to meet the deflection ratings that are going to be acceptable for your tile. OSB panels also are affected by moisture. Plywood is affected by moisture. I know back when I was contracting, we had a situation where the plywood got wet and it literally pulled itself through the screws that were holding it down to the floor. So all of the moisture that we have to consider here within a solid can make a big difference in our installation. Knowing when to install over them is something that we have to check with manufacturers in order to make sure that we are doing it correctly. When we think of manufacturers' instructions, some of these instructions, for example, when we talk about concrete, having to cure 28 days, that's a very general designation. As we see here in the list, there are many things that could affect concrete that could extend cure times, such as placement techniques, how much water is used, whether there's a vapor retarder underneath the slab. And when we think about additions to older buildings where trenches are cut and vapor retarders are damaged, all of these are going to affect how much moisture is going to come through in that particular area. Affected by temperature. Years ago, we had a contractor from Norway tell us that he installed tile in November, and when the concrete slab cured, or it actually unfroze in April, then what happened was all of his tile failed, because the concrete now is going to change because of the amount of moisture that's in it after freezing for so many months. Climatic conditions on a site can also affect how long a concrete slab is going to cure, and also the fact that HVAC is not turned on for an extended period of time, and you really don't know how much moisture is in that slab or in that groundwater below it. Also, when we think about additives and curing agents, they're also used, and we'll talk a little bit later as how they can affect installations. But all of these things make concrete itself a very complicated material, and there's not always a line in the sand where you can say 28 days is a perfect time in order to install tile or stone. When we think about the overall assembly, that's what's really important to consider, in that it's not just the substrate, but it's also all the materials that are going to be used. For example, with mortar, there are advertisements for mortar that say there's no minimum cure time for going over a concrete slab. And when we look back at the picture that we showed earlier of the efflorescence underneath the tile, what did that show? It showed, well, yes, the mortar wasn't broken down, but moisture did affect that installation. Same thing with grouts. It'll take a longer time for the mortar to cure. How is that going to affect the grouts that you're using? So if you're using a cement grout, that cement grout could effloresce. If you're using a premixed grouts dry by evaporation. So if there's more moisture coming up from underneath it into the grout and around the grout, surrounding the grout, it's not going to dry as fast as it normally would. And occasionally we see this condition where epoxy grouts are used, and because of the moisture vapor underneath these large format tiles, and now you have an impervious epoxy that's placed over those joints, the air pushes the epoxy during its cure time, just pushes the grout up, and you get these volcanoes that happen afterward. You may also experience efflorescence coming through capillaries or pinholes or little areas on the edges of your tile with all of these grouts, and that would definitely affect the entire assembly. So considering whether there's moisture in the slab or in the substrate, it makes a big difference as to whether we're going to be successful or not. When we think about other products that are used in the assembly, such as levelers and patches, if you read the data sheets for most levelers and most patches, they're not designed for wet areas. They have materials in them, formulations where you can get delayed expansion. And that's a nightmare for a project where now you have leveler that literally is pulling itself off of the slab and cracking. And those conditions could be really damaging to the entire project, and they may not happen for months afterward, but it could be from excessive moisture. Same thing with membranes. Not all membranes are recommended for these type of applications. Some have a range, and we'll talk about ranges a little bit later as to where they're acceptable and where they're not. And if you've been installing over damp materials, you'll see that some of these membranes can blister up like sheet vinyl because of the moisture vapor that's in a mortar bed or moisture that's in a concrete slab. And when we think about materials themselves, back in the day when I installed, we always thought, well, if we use quarry tile, we wouldn't have any issues on the project because quarry breathes and we have these nice big grout joints that we no longer have. And moisture will get out and it won't be a problem. But if that happens to an owner and you get an excessive amount of efflorescence on the top of the tile or through the tile, that also is considered a failure because now you have to go back and deal with the fact that it happened. And everyone blames the contractor, and you have to deal with the fact that you have to remove efflorescence in order to make the customer happy. And the problem also could be is that efflorescence could continue or come back. So considering moisture vapor emissions is important. It's not something that tile contractors traditionally are concerned about because, again, we go back to floor covering, they've been more susceptible to these issues. But when we think about what occurs in a concrete slab, where you have a higher pH at the surface, you have alkalinity there where it's going to possibly cause efflorescence, cause expansive materials or minerals to form, then you could have failure or you could have damage to your membranes or damage to your grout. So all this is really important to consider. It's not our responsibility to address those issues and be responsible for them, but if we're on a commercial project, it's something that we should check with the general contractor to see what the condition of the slab is. If we're on a residential project, we can also look for not only signs of moisture, and we'll show you a little test that you can do, or look at the ground around the building and see if there's any conditions that could lead to hydrostatic, where you're going to have literal water coming up to the surface, or where you could have areas where a lack of drainage, especially in construction, you'll see areas where moisture and water is going to come up against the building. All of those are things that you could consider. Not that you're responsible for them, but you need to consider it so that this doesn't happen to you. Because after it happens, explaining and understanding and getting an owner or a homeowner to understand exactly what happened is always a difficult thing. And you never want to be in a situation if you can avoid it in the future. If we talk about natural stone, we think about it as a rock. It's a rock that's existed out in nature, natural stone, for centuries. And when we consider whether it could be affected by moisture, especially in a slab, without a doubt, stone can be as well. When we consider that moisture is going to find its way up through into a building, as we see here, we see the efflorescence forming on the brick. Well, what happened to the stone is it's spalled. and it spalled in all the areas where there was a high concentration of moisture. And this moisture is not evident when they installed it, otherwise they would have taken some action. But after they've installed it, it happened. And I remember walking through a mall, and I saw an area where all the stone was spalled, and I thought, well, maybe they did that purposely because they wanted a non-slip area when they walked into the entry of the mall. And then later on, I found out that the contractor had to go back and remove all the stone and replace it because they had a high moisture problem. So when you consider natural stone can also be affected by moisture. Also, there are some stones that have high mineral or higher iron content, and they can be affected by moisture. And so depending on how we treat moisture, sometimes we can even six-side seal stone with special types of sealers in order to help moisture or keep moisture from affecting the stone. It's never something that you can 100% guarantee, but it is something that you can consider. We all know that stone can show some moisture through. Now, this isn't a good installation. You can tell exactly what happened here, but it does show that stone can be discolored as well from excessive amounts of moisture. When we think about how it's just being discolored from a thin-set mortar being underneath the stone, and we consider what could happen over time when a slab has a lot of moisture. So the story on this picture is we installed it with installed some new tiles into an old installation, and of course the thin set made the stone bleach out white. Well, we all know that's not what happened, but the amount of moisture that was in the slab affected the stone and therefore changed the color. So again, it's a situation where none of us want to be in, but obviously this could happen, and it's all because of moisture. And moisture has so many effects that could be damaging to tile and stone that we need to be aware of them and consider them. For example, substrates move because of moisture. We all know that when concrete is first placed, the surface of the concrete dries out faster than the underside. So when the top side dries out, it tends to curl upward. And what happens later is when the installers come in to install tile, they realize that although it was placed flat, that later on when they go back and check it with a straight edge, you'll see that slabs have done some curling. And if you're not aware of the Division 3 versus Division 9 document, you can find it online, and that definitely will help you explain it to an owner that concrete is going to change shape over time due to its losing moisture. And so even though they could specify really high numbers for floor flatness and floor level, even though they specify it, even though it's placed that way, it's only measured within the first 72 hours of placement. Months later, maybe a year later, when the tile installers come, absolutely that slab is not going to be as flat as when it was first placed. So moisture will definitely play a factor. Now, after the building is enclosed, after you have an equalizing of moisture within the slab, because now the HVAC has helped to stabilize the environment, and also you have a floor covering tile over the surface of the concrete, maybe a membrane, the moisture in the slab equalizes. Well, what happens is many times the concrete will lay flat, and it will go back to its original position, and when it does, what that means for the tile installation is that the tile is longer than the concrete slab. And without enough movement joints, or even with proper movement joints, depending on how much the slab relaxes, you could have tile delamination and damage. And so now, again, they call back the contractor, what did you do wrong? But obviously, it's beyond the contractor's control. But understanding moisture and understanding how it can affect the concrete can help you explain it afterward, or you can help your owner understand why there's a need for movement joints, which is always something that we're arguing about in our industry. Now, in many applications, the general contractor will apply a curing compound to help prevent curling of the slab, keeping moisture within the slab so that it lays flat. Well, many of us have found over the years that the application of a curing compound can cause bond loss, because it's very difficult for a mortar that's designed to grab hold to a concrete slab that's porous. In order for it to bond to it, we need some type of absorption. On the left-hand side, you see someone using a little droplet in order to determine whether the concrete slab is absorptive. For those of you who are not aware, there's a practice in the resilient floor industry that was designed through ASTM, and it's ASTM F3191, and that's a literal practice that you can use to establish a criteria as to whether a slab is absorptive or not. One of the things that will change in that practice is when you drop the droplet, it should be within a ½ an inch from the slab. If you drop it too high, it could give you a false negative because the water will just spread out and it'll look like it's absorbed. So that's one way to do it. On the right side, you can see that manufacturers can go in, especially if they're going to establish a 25-year or a lifetime warranty, they can go in and do testing of an assembly over an area where there's a curing compound and give you a realistic idea as to the actual strengths that you're going to get bonding your tile to that slab. I'd like to tell you a little story about Southern California. I originally, being from the East Coast, it's a little different as far as climate. It goes from Connecticut or Florida, and also those areas where I lived, and then coming to Southern California. When I moved here in 2010, immediately the drought got started in Southern California. And it was only last year that we started to get some torrential rains, and we're finally out of a drought season. Well, what we've noticed is a rash of installations where there's been no moisture or very little moisture in the assembly. And now all of a sudden, with all the rain and all the moisture, it's caused some substantial thermal expansion. And as you can see from the picture here, we're seeing a condition where drip edges were not installed properly. Water's getting behind the system, and that water's causing a great amount of thermal expansion. And we are literally seeing tiles fall off the building. So nothing more dangerous than a 12 by 24 or a 2 foot by 2 foot tile falling off 30 feet off of a building. And we're seeing it primarily because the attention to detail with the drip edge was not done correctly. We're also seeing the usual suspects where areas were spot bonded. And with every failure, every one of us knows it's not just one thing that causes a failure. So we know that this was done incorrectly, but the issue is according to the building movement and thermal expansion, due to moisture getting into the system, getting into the materials, that's what causes the failure. It's a combination of the two. And we see it's even worse when you install over a membrane and you have that type of practice. When moisture gets to it, you see in the top right there's a little palm tree. It'll show you that's South Florida. And in those areas, you'll see that the moisture gets to the mortar, things expand and contract, expand and contract due to moisture and thermal changes. And the next thing you know, you have tile falling off the building. So we've talked quite a bit about vapor and how it gets into a material. But one of the other factors that's commonly overlooked is condensation during installation. And we've seen that it is definitely a factor. And let's consider moisture a little bit. Sorry about the formatting, we had a little changes there when it moved. But if you look at the moisture vapor emissions, there's different tests that can be done in order to determine how much moisture is in your substrate and how much you're going to deal with. It's not often clear as to what are acceptable or not acceptable. Some manufacturers will give you actual numbers, some will give you ranges. It is a really difficult thing to determine because there's so many factors that are involved in each individual project. But these are the ASTM methods for measurement. And it's interesting, all these measurements were designed for floor covering, and now we're using them in order to consider what will be good for tile installations. For example, 2170, relative humidity, that measures the amount of moisture that's in a substrate like a concrete slab. And when we think of the calcium chloride testing, that measures how much moisture is escaping from the slab. A moisture meter, a pin meter, or other meters that you put on the surface of the concrete will tell you how much moisture is in the upper surface of the slab. And then there's a representative test that's very easy to do, and tape down a piece of plastic over a slab and see if there's a lot of moisture that you'll find the next day coming up underneath the plastic sheet. All of these are going to indicate how much moisture is there at the time of installation. So it gives you an idea of what to deal with in order to be able to test, but it doesn't tell you long term how things are going to be. It's only indicative of that particular moment when you do the installation. The numbers that you see on the right-hand side are relatively safe numbers depending on the type of products you use. Most products that you're going to use in your assembly, be it levelers, be it membranes, grouts, mortars, if you're less than or equal to 85% RH, it's typically not a problem. When you measure by calcium chloride, 3% is a great number, but typically we're running into concrete slabs that are around 5 pounds as opposed to 3 pounds. 3 pounds you might see in an older installation. And then up to 12 pounds for some membranes that could be applied over the concrete. But all products are fall somewhere in between that, and you really need to check with your manufacturer to make sure that their product is recommended for that type of condition. When we think about a moisture meter helps you understand materials that are not going to really experience moisture vapor coming up from a slab. For example, if you're checking a plaster coat or a render coat, you're checking a mortar bed. Typically mortar beds are over waterproof membranes, and you're concerned because the temperature's been cold and the material that you're looking at looks very dark, you think there's a lot of moisture there, you can use a moisture meter, a concrete moisture meter, and check it. And if it's less than 5%, you're typically safe in order to install most products over that. One of the conditions that we see all the time is that a lot of commercial projects are being tested when the HVAC is not operating or there's temporary heating. And if you look at the ASTM tests, they'll tell you that they're just not relevant. If you're doing those in those conditions, you're really not getting a good reading. Or you're getting a false positive where they'll check the slab and it's like, well, we've got 99% RH. Well, because the HVAC is not on, you really don't know what the conditions are. You're shooting in the dark. When we consider moisture or condensation of materials within the assembly, it's another consideration. One thing we've run into quite a bit is frozen tile, especially those that are cement-made tiles, or we have natural stone where they're stored outside, brought in the night before, but because they're on a pallet, the internal areas there, the internal boxes are still very, very cold. And when they meet an area in the inside of the building where it's warmer, you get condensation. You install the tile, all the water seeps to the bottom, you get condensation between your adhesive mortar and your tile, and the next thing you know, you have loose tile. It's the same thing when you think about a damp slab, or you think about the exterior of a building where you do a scratch and brown, and you're maybe on the coast, or you're in a situation where it's cold and then it starts to warm up. In the morning, you get dew that's on the surface. All of that could be a bond breaker. It's even worse when you go over a membrane. If you have dew over the surface, if you don't wipe it down, you definitely could have some failure. As mentioned in a previous slide, we talk about plywood and OSB. They definitely can be affected by moisture, condensation. All of these things can be a factor, and they cause a bond breaker for mortars. One of the little-known factors with self-leveling products, for example, is if you read manufacturer's instructions, they tell you that there should not be a wind that goes over the surface of the leveler. If a strong wind or a strong air force is over the surface of the leveler, it'll dry out the surface, and you can get some very soft surface on your leveler. So some people will plastic off an area, and we had one area that was entirely plastic off, and the temperature was very high, the humidity was very high, and there was condensation on the surface of the leveler, also because the levelers incorporate a lot of water in their mixture, and the surface became very, very soft because it couldn't cure out because of the dew point and because of the amount of moisture that was on the surface of the leveler. So although you want to protect your levelers from a strong wind, you do have to have air, and you have to let that humidity get out somehow. With grouts are also a situation where we've seen many times with plank tiles. The plank tiles are installed, they're grouted, and then the next day the installer will come back and go, why do I have all of these spots on the surface of the grout in all these areas? It's the right color in most of it, but I have these spots throughout. Where did those spots come from? Well, many times the surface of plank tiles are variegated or profiled, and what happens is the water or moisture from your last cleanup is sitting there. And if the temperature is just right, the moisture will stay there, the water will stay there, and it'll finally run off into your grout joints, and the moisture that goes into the surface of the grout can discolor it or actually make it cure out soft. So a good practice with plank tiles is to do a nice wipe down with a towel after you're done grouting in order to remove all that excessive water and not have moisture affect the surface of your grout. Many of us are aware of green marble, where it could be moisture sensitive, but there are moisture sensitive limestones and travertines, and especially if you place these materials over a deformable membrane, such as a peel and stick membrane, especially if you were to have to do some buildup of mortar underneath that tile. So now you have an impervious membrane with a substantial amount of mortar and moisture, and that moisture could go into your stone and you won't see the effects. It could be up to 40 days. And then all of a sudden your stone will start to warp. And if you've ever seen it, it's a very strange and eerie thing to see stone actually deform like that. But definitely it can happen through moisture. When we think about glass tile is another product that it's beautiful, it's very popular, but when we consider how moisture affects installation and installation materials, and then after the fact when the installation is in service, how the glass tile could be affected by moisture, we see what's called ghosting on the left side, where moisture is leaving the mortar and it's underneath the tile, and we see a discoloration through the transparent tile. And some of the glass tile manufacturers do not recommend using membranes underneath their glass tile for that very reason. The mortar needs a place to escape, otherwise it could affect the appearance of the transparent glass tile. On the right-hand side, we see that there's definitely a need for extra movement joints, or effective movement joints in order to handle the fact that moisture and thermal expansion is going to cause those tiles to grow. Now, what could also happen with a slab or an area that has excessive moisture is not just from moisture vapor, but it could happen from groundwater. And sometimes you could go back to a project like on this one here where we went back and someone said, well, the grout's all discolored. Why is the grout discolored? Well, when he started cutting away the grout to take a sample, he saw that there was groundwater and moisture, and that definitely affected the installation. And after the fact is a lot harder to fix it than before the fact. So we have to ask ourselves, well, what steps can we take? What products can we use? How can we address moisture ahead of time so we don't run into these situations? Well, there are some rock-solid areas that we can address, things that are definitely proven to handle moisture up to 99% relative humidity, up to 25 pounds of moisture vapor is measured by calcium chloride, and those are products that meet the ASTM for a two-component epoxy moisture mitigation membrane. And these products are installed over the concrete. You use either a special primer or a sand broadcast, and you're able to install your tile directly over it. And then here, this actually blocks moisture, slows it down so much that moisture is not really a factor in your tile installation. So if you're specifying a large project, you have some concerns about moisture, this is your best opportunity to handle that. The other way that moisture is managed is by using uncoupling mats. And uncoupling mats, because of their geometric shapes, they have airspace that's underneath the mat. As you can see here through the scrim, you see those air pockets. So in those areas, the moisture will come up and it won't affect your installation because A, it's blocked by the mat, but it also is going to equalize underneath your installation. And so that will release the moisture vapor. So the other one was block it. This one is release it. And there are other situations where you might have moisture, for example, in a mortar bed, or you might have moisture in a plaster coat or render, and it's not something that's going to continue. It's only something that is going to occur during the curing of the material. Well, in these, you can allow passage of the moisture vapor because it's very limited and not be affected by blistering and so on by using certain membranes for crack isolation or waterproofing that definitely will allow the passage of moisture vapor and not cause blistering or a failure. Another way to help with moisture is to eliminate excessive moisture by using rapid setting products. Most rapid setting products are not just fast drying, but they're fast curing. And fast curing is really what's important, because fast curing means it uses up a lot of the moisture in the curing process. And when that happens, the amount of moisture that's left over should not affect any of the installation materials or affect the tile or stone. As you can see here, on the left-hand side, there are mortars that dry within an hour, and it's not just drying, they're curing. If you put a moisture meter on them after an hour and a half, they meet that less than 5% moisture as measured by the meter. So it's a very safe process to do your mortar bed, not have to wait for 4 days to let it cure out and install your tile directly over it. You could also have products that are patches or ramping materials that can be mixed and finished like concrete, and yet in an hour and a half, you can install waterproofing or install your tile over it and not have to worry about moisture because it eliminates the moisture. So the reality is moisture is always going to be here. It's always something that's going to be a factor. If we don't prepare for it, if we don't get ready for it, it's going to cause some problems with our installations. None of us want that. So being prepared, thinking about an installation, think about your project, and consider the products that you could use, the tests that you can do ahead of time, and also mitigate these factors before they occur. Because as we all know, moisture is going to be here, and we're just going to have to learn to live with it. And that's the kind of moisture that I think all of us are looking forward to enjoying, as opposed to going back to a failed project. So we have a few minutes, and if you have any questions, Jim will be coming back on, and we'll be glad to address them if we can.
Michael, great job. Lots of great information there, and I want to thank all the attendees for attending today and participating. And just beware, you will be getting an invite soon for our next webinar. So far, Michael, we do not have any questions. I'm kind of just waiting to see here if any, anything comes up or anything. And I want everyone to know, if you need to get a hold of Michael, his phone number and email are up on the screen, and Custom Building Products website information is there also. Other than that, Michael, it looks like you did such a good job presenting the information and giving some ideas on what to think about and how to move forward when we have moisture in our job site situation. So I guess we're going to say goodbye to everyone. Thank you, and do not hesitate to email me if you're interested in the archived version. Appreciate it. Thank you very much. Thanks, Michael.
Yep. Thank you. Thank you, everybody.